My name is Rob. We'll do an intro in a second, but first I want to get to the problem statement. What we're trying to do is we want to have data records that relate to other data records, all on chain and gas efficient. That's the problem to solve right there. Because if we can do that, we can extend them all the way down. So if A relates to B and B relates to C and C relates to D and so forth, then we have a solution. So my name is Rob Green. I'm currently a co-founder of Runic Labs, a VC-backed crypto product development group. I came off of recently 4 years at Coinbase. I got there after developing with a team a product called Paradex in 2017, which was a DeFi exchange on Ethereum mainnet. In the past, I've worked for companies like IBM, but I've spent a lot of time being an indie game developer over the years, and I'm a lifetime computer and technology hobbyist. Ultimately, I don't think it matters that much. I just felt like I had to say that, but the concepts matter far more than the person, so let's get into it. So basic glossary here for what I'm going to talk about today. I'm going to go over it with a little bit of detail, even though some of the stuff you're going to roll your eyes and say, Guy, I know what a 721 is. That's fine. But the primitives are important. So ERC 721 is the NFT standard. It's what many NFTs are today, and if they're not that, they're usually an ERC 1155. But an 1155 is actually only somewhat considered an NFT standard. It's a multi-token standard, and more on that in a minute. Another really interesting one, and I bring this up because I get asked about this one a lot, is ERC 6551. And if you're not familiar with 6551, it's an NFT-bound account standard that I'll cover in a minute too. The next term is metadata. We all know about NFT metadata. I'm going to go ahead and call that a record today as I go further in, but it's data associated with any one of these three things. And then a relation, we're going to define a relation as a record with a to-one or a too-many relationship with another record. So, starting on ERC 721s, these things are old. We've had these since 2017. These were pretty much the foundation of the big NFT boom that happened. But the two really unique items or attributes about ERC 721s is that they are a unique address with metadata. And by unique address, I don't mean just the contract address. I mean the uniquely addressable piece of information. So if you take the address plus the token ID, that describes a unique piece of data, which is a metadata URL, which leads you to metadata JSON, right? And so in my example on the second line, if you see well, it's Taco Foods written out in hex, okay? Taco Foods, token ID 55. If we look that up, it would take us hypothetically to mydata.com/55.json, which would have something hopefully unique about token ID 55 at that address, right? So that's a unique piece of data. The other thing that's a primary attribute about 721s is they have ownership. That if you take this little bit of solidity here, cast it to a 721, Taco Foods owner of 55, and ABC123, that address owns it, right? Now, when I was first working with 721s, I had people saying, well, when are you going to do 1155s? Because 1155s are better. 1155s do more. 1155s they're just 721s with batch transfer functions. But it turns out that's not exactly it. I don't think they're going to replace 721s, and I don't think they're truly a superset of 721s. I think they're a little bit different. The big thing about 1155s is that they are a balance of a token ID for an address. They don't use the word address anymore. They call it account, and there's a good reason for this. I assume, is everyone here familiar with the ERC20s? Super basic, right? An 1155 is more like an ERC20 for each token ID, being that you can give a balance of to a user. So I don't give you one, I can give you five, right? And so if the Taco Foods contract is an 1155, and we check the balance of account ABC123 for token ID 55, it'll say your balance is 4, right? The big thing about 1155 is there's no owner of. That's not a standard function on 1155 because instead there's just a balance. And that has implications when you want to get into data relations. One of the biggest things is that 1155s have a single metadata URL for the entirety of a token ID. Okay, so there's not like if ABC123 has 5 and DEF555 has 20, they have the same metadata. That first user's 5 can't be different than the other user's 20. But 1155 is super awesome at what it is, right? One of my favorite use cases for it are commodity items. So say you're building an app and you want to have something where you're issuing gold, silver, some kind of monies, right? Bricks, let's say, in some kind of app. If you can see, this would be an example sort of table that you would have in an 1155. And so we can see that there's one account, 0012, that has token ID 5,000 of token ID 5, 12 of token ID 32, and then this other account has 33 of token ID 32, and then these other two accounts, say this is some, let's say token ID is like the in-game money or currency of some kind, and this account has 821,000, and that account has 5.9 million. It's really, really awesome at this because with one call, you can transfer millions of the quantity of that token ID to another user, and that's something that 721 just doesn't do, right? So for this use case, it's incredible. But if you've heard about 6551s, and there was a lot of hype about them in the last year where people were saying, what about 6551s? These are gonna enable everything. They're gonna enable all the composition, all the relational data, all these things. Yes and no. 6551s are also amazing, and they're very, very cool at what they do. Ultimately, a 6551 is a proxy account owned by a 721. For every 6551, there is a 721 underpinning it. And the way that works is that if Taco Foods, let's say, is now a 6551 contract, I can call it, and if I own the 721, one of the token ID at the 721 that creates that address, I can execute code on chain on behalf of that address. So the other contracts see the call coming from that 6551 account address. And that's super powerful because that makes it so that if you own a 6551 account, again, underpinned by 721, if you own that account, you can own a slew of NFTs, you can have a balance. Let's say you want to collect a certain bunch of NFTs or something like that, and then you want to sell them. You want to sell them or transfer them to somebody. You don't have to transfer them one by one. You can sell the token ID at the 721 that owns all of it. And that's something that you can do actually fairly trivially with a 6551. But there are some considerations you need to make if you want to use a 6551 in this way. If you want to have a relational hierarchy with that, you're going to have the 6551 721 problem, meaning that the first 6551 that you own, you have to actually own the 721. And if you want that 6551 to own another 721, and you want and that owns a 6550, that controls a 6551, you've got multiple hops to go through to assert the ownership of that. You have to have knowledge of both. So ultimately, 721 is still the primitive in a 6551. And a lot of the things that you want to do with hierarchy, you can actually do directly with 721s. 6551s also are a little more difficult because with a 721, you'll know if you go to the Etherscan or whatever, and you look at the address, you can find, well, what collection is this, right? How many were issued? I can find out things about it. But if all you know is the address, the account address of a 6551, and you don't know anything else about it because that's what you're going to have your app own, you don't really know what collection it belongs to. You need more data than that. The address alone doesn't tell you quite enough about it. Also, making contract calls and front ends on top of 6551s is another layer of development that you have to do to be able to handle all the proxying through and all that sort of stuff. So let's imagine 721s have evolved a little bit for a second, okay? And instead of thinking them like, you know, I know a lot of people think of 721s as like PFPs, like all that is some art somewhere on a server. But let's get rid of the idea for a second, and let's think of each 721 as an address, like a table with a schema, okay? And then for each token ID, let's make that like the primary key. And instead of metadata, let's just call it the record. But as you can see, off-chain data, off-chain JSON is a problem. So if Taco Foods, again, is a 721, token ID 55 is at this URL, I have to go off-chain, and I have to go look that up, and I can go read this JSON that says that this relates to FF11, token ID 8. Then I have to go back on-chain. I have to read about FF11, token ID 8. I have to go look that up. I have to go off-chain again to get the data. This isn't that helpful, right? If I want to write a really robust on-chain app, there's too much that exists in servers that are outside of what my transaction can even do, what my contract can do. I also would then have to add a server to do that. So if we can bring the data on-chain, we can solve that atomicity problem. Okay, so let's imagine this is all on-chain. So we have a table here of data, and the metadata, imagine that there's some on-chain representation of this. If I can read in a contract that Taco Foods 55 relates to FF11.8, and FF11.8 has this data in it, I can now write a contract that says, hey, if you have FF11, any token ID on it, I know what the metadata scheme is, and if your happiness is over 10, I'm going to award you with something, or we're going to be able to perform some action. Right? And so now these relationships actually become meaningful because all of this is done on-chain, and we can also have data integrity. We don't have a situation where some server's offline, someone changed data, someone pulled the plug. These relationships can be created with rejections if, let's say, there's a violation or something like that. So you're guaranteed to have data integrity. So real relationships start to look like this. A 721 address and a token ID relates to another 721 address and a token ID. And once you bring the metadata online, this all starts to become usable. So how do we go from just talking about it or having some like esoteric sort of code that we wrote that doesn't matter to anybody else and make this usable, make this interoperable? First, we have to ask ourselves, what does it mean to have on-chain metadata? What about the ABI for interfacing between contracts that have on-chain metadata? And how do we discover other contracts and interoperate between applications and contracts? And if you start with some definition, just some definition of a metadata schema on-chain, given this one, this is a very minimal form, but with this is complete enough to be usable, right? So if I define my metadata as having an array of these, and each one of these is an entry, and so this represents a field. Each field has an ID, a field type, maybe the field type's like uint256 or uint8 or address, right? A field count, so I could say I have 8 uint256s, so now it's a static array. And then a key, a human readable key, so I can look these things up, or so I can generate an ABI just from reading the metadata on-chain. And you add this function. So at the bottom here, if you can see the schema function, you add this function to your 721. Now you're allowing introspection. Okay, so here's an example schema doing this. Those same 4 fields, IDs 1 through 4, field types, uint8, uint32, string, and here's a key one, a relation field type. It doesn't have to be a primitive in Ethereum. You can write a system that is aware of a relation with another 721, and you can have that be meaningful in a standard, right? And so we have keys on the side. I don't know if I'm blocking it over here, trying not to. Keys on the side where these are the human readable parts, and these could also be used to generate an ABI. And all of this gives you discoverability. So if I have a standard with this, I can call a contract, I can read the schema, I can determine that these functions must exist, I can know their return types, and I can interoperate with it without having to know anything about the actual contract code itself. In fact, I don't have to publish the code. It's fine. The schema tells me everything I need to know. So you might be asking yourself, okay, on-chain sounds cool. What about gas usage? I mean, wouldn't this have happened before if it was cheap and easy to do? Well, it turns out that if you just do this naively, if you say, all right, I'm going to write an application and I'm going to put all of my stuff on-chain, that it can get gas heavy. Ethereum mainnet is a problem. It is expensive. But there are actually a number of ways that you can optimize to reduce it. We were doing some game design to do a game that would run off-chain and do rewards on-chain, but then we wanted to rewrite the entire game as Web3 and put it on-chain. And the first thing we ran into was we don't need to have 20 different fields. We don't need to have a struct. And by the way, if you think that Ethereum packs structs efficiently, it does. But has anyone used Compiler Explorer before in the past? There's a tool called Compiler Explorer. It supports Solidity. If you care about efficiency, I recommend dropping your contract into it and see what it does. I believe it's at godbolt.org. But it will tell you some very revealing things that happen that consume a whole lot of gas. But you don't have to do that. You can pack your data in and you can write your own routines that make it so that you consume like one field, like two storage slots, and you cut your gas usage down dramatically to get your data online. Also, L2s have done an amazing job mitigating the costs. It's an order of magnitude cheaper to use an L2, and those didn't exist previously. So can we make a full relational database management system on-chain with queries and indexes and all that stuff? Not really. Not exactly the way you're thinking. It is so prohibitive to scan through large amounts of data on-chain. It's so gas prohibitive to do that that's not really the goal. But the main thing is that we can get a lot of utility just having the relations and the core data that we need on-chain, and we can bring atomic transactions into play and have data integrity, have ownership, have inheritance, and stuff like that. We don't need a full RDBMS to do it. So once you're in atomic transactions, and what I mean by that is not reaching out to servers to read metadata, keeping it on-chain. You can create relations with data integrity. You can inherit, meaning that if I have an NFT, a 721 that's a sword, and I have another 721 that's called a red gem, and I want to assign the red gem to the sword to power it up, and it's a one-time use rule in my game, I can have that relation, and now I can make it so the owner of that red gem 721 is the owner of the sword, so that if that user ever transfers that sword, the gem just goes with it. It's still there, the history's there, the relation's there, but that's something very powerful that I can do, and I can guarantee it on-chain with an atomic transaction. Okay, and in fact, you can get down to where entire applications can deploy with only a client where you don't need server-side components at all if you do this. For some applications, obviously it varies. And you can take, if applications do this, you end up being able to bootstrap off of one another, where because someone's using the data, you can start adding some data and gating off of theirs. So existing 721s and 1155s aren't totally out. You don't have to rewrite everything. You can extend them permissionlessly. You can integrate on-chain metadata with what's existing off-chain. In my group, we call it patching. And all the stuff that I'm talking about, I wish I could have added more code, but we've been working on this for about a year, and there's thousands of lines of code to look at. But we do have an implementation, but we've worked on all these features, and there's a whole lot there, and I could talk for quite a while longer about this, but that's pretty much the list. If you're interested in our implementation of this and what we do, or you just want to use it as a reference, got a number of links here, and I'll give you a QR code at the very end if you want the deck and you want all the links as well. And I believe the future of blockchain is more data on-chain, richer data on-chain. I think that you're going to have app interoperability, where an app shows up, does something cool, and another app gets an idea based on that one and does something cool up to piggyback it. And I think that you're going to start to have apps with EVM-based backends that consumers are unaware of. And what I mean by that is you can apply the parent test. Is my parent using something that's got a blockchain behind it and they don't even know? Right? I think that's going to happen. This is a QR code. Please, for the deck, please scan it if you want access to the resources, or you want to be able to review or contact me or anything like that. And I have 15 seconds left, so I'm going to end there. Thank you.